Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Equal Sum and Killer Cages by Railman. And I'm assuming it's going to have equal sum lines, or actually I guess they're called region sum lines usually. And we have killer cages, definitely. So let's get to the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 once in every row, column, and box. We also have digits on the positive diagonal may not repeat, which is this diagonal here. And digits on the negative diagonal cannot repeat, which is this diagonal here. So there are no repeats in any row, column, or box, and along the main diagonals. We have digits in cages cannot repeat and must sum to the total shown in the top left corner of the cage. So for example, if this were say a 3, this would have to be a 7 because these two digits must add up to 10, which is the number in the top left corner of the cage. And again, you cannot have repeats in cages either. So this cannot be something like, say, 3, 3, and 9, because you have a repeat in this cage, and that's not allowed. Okay, we also finally have box borders divide the blue line into segments with the same sum. So this segment must equal the same as these 7 digits because this is one segment, and then that must be equal to the sum of these 4 digits here. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. We have 7 digits here, which means they must sum up to at least 28, which is the minimum of 7 digits added up, which would be 1, 2, 3, 4, 5, 6, 7. But the thing is, that's equal to the sum of these 4 digits and these 4 digits. So you cannot have... You have to have 6 of these digits be the same. So that's at least 4, 5, 6, 7, 8, and 9 for the sums adding up, which is 39. So these 6 digits added up is 39 at most. And then you can add another digit here and another digit here. So that could be potentially 9 and 9, but it has to add up to an even number because the sum of this is equal to the sum of this. So that technically be 9 and 8 we have at minimum. At maximum, sorry. So, yeah, 4, 5, 6, 7, 8, 9 is 39. Plus 8 and 9, which is 17. So 39 plus 8 and 9 equals... what is it? 39 plus 17 is equal to 56. 56 divided by 2 is exactly 28, which is the minimum this region can sum to. So this must be 28, and this must be 28. That means this must be the digits 1 through 7 here. This has to be 8 or 9. This is 8 or 9 here. And these digits, you could have 9 and 9 potentially here. So that means this could be 3, 5, 6, 7, 8, 9 here. So you have 18. So 58 minus 18. Wait, no, that doesn't work. No, 56. Sorry, 56 minus 18 is 38. So this could be essentially 3, 4, 5, 3, 5, 6, 7, 8, 9, or it's 4, 5, 6, 7, 8, 9. So this is 8 or 9. This is 8 or 9. And we have 3, 4, 5, 6, 7, 8, 9. With a guaranteed 5, 6, 7, 8, 9 here or here. So this cannot be 5, 6, 7. That means this is guaranteed 1 and 2 on this diagonal. So this cannot be 1 or 2. This can't be 1 or 2. And this can't be 1 or 2. These three digits add up to 24, so it's 7, 8, 9, because that's the only unique digits which can ever add up to 24 with 3 unique digits. That means 7, 8, 9 cannot appear on the positive diagonal anywhere in box, except for this cell here in box 7 and this cell in box 3. So 8 and 9 cannot be along this positive diagonal in box 5. So this must be an 8-9 pair here. Well, 7 then cannot be in the diagonal of box, on the positive diagonal in box 3 or in box 7. So it must be one of these two cells. So this cannot be 7 here. We are guaranteed a 7 is one of these. This is 8-9, 8-9 pair. They're different 8 9s because there are no repeats on the positive diagonal. So this cannot be 8 or 9 here, and this cannot be 8 or 9 here. We also have, we have an 8-9 pair in row 2 and an 8-9 pair in row 7, which eliminates 8 and 9 in the rest of the row. So this cannot be 8 or 9. This is 7, which eliminates 7 here. And this cannot be 8 or 9. Because of the 8-9 pair in the row. So this is 7, which means this can't be 7 here. So this can't be 7, and this can't be 7, because of the 7 in the row and the 7 in the column here. There's no 7 here. This can't be 7, and this can't be 7, because of the 7 in the row and the 7 in the column here. This can only be 5, 9, or 6, 8 here to add up to 14. This adds up to 18 without an 8 or a 9. That means the most this could be is 5, 6, and 7, which adds up to 18 exactly. So if we try to decrease any of the digits, then you would never add up to 18. So this must be a 5, 6, 7 triplet, which means this can't be 5 or 6 because of the 5, 6, 7 triplet in the column. So this is 3 or 4, which means along here, we have along this negative diagonal, we have a 1, 2, 3, 4 quadruplet, which eliminates 1, 2, 3, 4 in the rest of the diagonal. So this cannot be 3 or 4. So this has to have a 3 or 4 here. 3 to add up to 20. You cannot ever have a 3 add up with 3 other unique digits to add up to 28. Right? It's 3, 7, 8, 9 at most, which is 27. So this must be a 4, which means this can't be 4 along this diagonal. So that means we have a 1, 2, 3. This 4 has to be with 7, 8, 9. So this can't be 7 because of the 7 in the column. So we have 8, 9 here, and this must be 7 here. That eliminates 7 in the rest of the diagonal, so this can't be 7. We have a 1, 2, 3 triplet along the negative diagonal, and specifically in box 5, which eliminates 1, 2, and 3 in the rest of box 5, so this can't be 3. This must be a 5, 6, 8, 9 quadruplet in box 1. So that eliminates 5, 6, 8, 9 in the rest of the box. This cannot be 1, 9, 2, 8, or 4, 6. So this is a 3, 7 pair, and this can't be 7 here. So this must be 3, which makes that 7. This adds up to 17 without an 8 or a 9. That means it's 5, 6, 7, or it has to be 4, 6, 7 here, because it's the only combination of digits without an 8, 9 that adds up to 17. So this is 4, 6, 7, which eliminates 4, 6, and 7 in the rest of the column. So this can't be 6, this is 5, this can't be 5, and this can't be 5. Remaining digits in column 2 are 1, 2, and 5. No, 1, 2, and 3. 3 cannot be here or here, so 3 must be here. So this has to be a 1, 2 pair here. That leaves the remaining digit in box 1 as a 4. So this is 4. Same thing in column 8. We have 1, 2, and 3 remaining. So this could be 1, 2, 3. This could be 1, 2, and this could be 1, 2, 3. Okay. This cage adds up to 7, and you cannot have 5 or 6 because of the 5, 6, 7 triplet here. So that eliminates 1, 6, and 2, 5. So this must be a 3, 4 pair here. Okay. That means the remaining digits in box 6 have to be 1, 2, 8, and 9. Obviously, this can't be 8 or 9 because of the 8, 9 pair in the column. So this is 1 or 2. And then we have 1, 2, 8, 9 here. Cannot be just both 8, 9 here because that would add up to 15. Sorry, that would add up to 17 already, and that's greater than 15. So this cannot be 1, 2. This is 8 or 9. We have an 8, 9, 8, 9 pair in row 6, which eliminates 8 and 9 in the rest of the row. This can't be 8 or 9. It's 5, 6, which forces this not to be 5 or 6 here. We have a 4, 6, 7 triplet in the box, so this can't be 6 anymore. So this is 5 and 9, adding up to 14. That eliminates 9 from here. It eliminates 9 from here. This 9 eliminates 9 from here. This 5 eliminates 5 from here, and 5 from here. We have a 4, 6, 7 triplet, which eliminates 4, 6, and 7 in the rest of row 6. So this must be 1, 2, or 3 here. Remaining digits in box 4 are 1, 2, 3, and 8. Okay. This can't be 3 because of the 3 in the column. To add up to 13, if you have 9 here, it's guaranteed to be 1 and 3. If it's 8 here, it could be 1, 4, or 2, 3, and those are the possibilities. Remaining digits in box 9 are 1, 2, 3, 5, 6. And this cannot be 3 because of the 3, 4 pair in the column. So 1, 2, 3, 5, 6. This can't be 3 either because of 3 in the row. Remaining digits in column 9. We cannot have 3, 4, 7, 8, 9. So it's 1, 2, 5, 6. 1, 2, 5, 6. This adds up to 15. With the 9, it cannot be 2, 4 because of the 4 in the row. It would have to be 1, 5. If it's 8 here, it could be 1, 6, and then 2, 5 as possibilities. Either way, we have a 1, 2, 5, 6 quadruplet in, cannot be 3, 4 here. So we have a 1, 2, 5, 6 quadruplet in row 3, which eliminates 1, 2, 5, 6 in the rest of the row. This can't be 6 then. So this is 8, which makes this 9, which makes that 8. 8 eliminates 8 here, so it's 9 and 6. This 8 eliminates 8 here, so it's 9 and 8. Remaining digits in row 3 then are 3 and 7. 7 cannot be here because it's 7 in the box, so this is 3, which makes the 7. That eliminates 3 from being here or here. Whereas the 3 in column 8, it has to be here. So this is 3, which eliminates 3 here. This can no longer be 1, 3, adding up to with 9 to add up to 13. It cannot be 2, 3, 8. So this has to be 1, 4, 8 here to add up to 13, which makes this 9. That leaves this as 1, 5 pair here to add up to 9, to add up to 15. So this is 1 and 5, which eliminates 1 here. So this is 2, which makes this 1. This can't be 1, 2, or 5. So this is 6, which eliminates 6 in the rest of the column. This 1, 4 pair eliminates 1 here because of the 1, 4 in the row. This can't be 8 because of the 8 in the column. This 9 eliminates 9 as a possibility here. 9 cannot be here or here, so 9 has to be here in box 6. Therefore, this is 8 with 1 or 2. If it's 1, 8, this is 6. If it's 2, 8, this has to be 5 then, to add up to 15. Okay. Remaining did okay, so this 1 here eliminates 1 in the rest of row 1. So this must be 2, and this must be 5. That eliminates 5 here, so it's 2 and 1, which means this cannot be 1 and 8. This is 2 and 8, which adds up with 5 to add up to 15. That eliminates 5 in the rest of the box. This one eliminates 1 in the rest of the row. This can't be 2. This 2 eliminates 2 here, so that's 1. This cannot be 1 or 2, so it's a 5, 6 pair here. 8 eliminates 8 here, so this is a 9, which makes that 8, 9, and 8 work there. Remaining digits in row 7. We have 5, 6, and 9. 9 cannot be either of these spots, so this must be 9 here. This can't be 5, so that makes this 6, which makes that 5. So 6 eliminates 6 on the positive diagonal. We have a 4, 7 pair, which eliminates 4 and 7 in the rest of the diagonal. So this is 1 or 2. It cannot be 1 because of the 1 in the row. So this is 2, which makes this 1, which means this can't be 1 here. This can't be 1 here. This 2 eliminates 2 in the rest of the column. So that makes this 3, 8, and 1, which forces this to be 2, which makes this 3 and 2. 2 eliminates 2 here, so it's 8 and 2. 3 eliminates 3 here, so it's 4 and 3. 4 eliminates 4 here, so it's 7 and 4. That leaves this as a 6. This 5 and 6 eliminates 5 and 6 here, so it's 7, 6, and 5. This can't be 4, 7, so that's 6, which makes this 4, which makes that a 7. 4 eliminates 4 here, so it's 1 and 4. 1 eliminates 1 here, so it's 5 and 1. And the rest we can do from normal Sudoku. We should have, where's the 1 in column 3? Cannot be, these are all filled out, cannot be here, so it must be here. Therefore, we have 8 ones. We know where the last 1 is. It's there. 2. 2 is pretty unrestricted, so that's not helpful. 3. 3 is also fairly unrestricted, so that's not helpful. 4. 4, remaining 4 in column 3 has to be here. Remaining 4 in column 7 has to be here. So we have 8 4s. We know where the last 4 has to be. It has to be there. 5s, it's not that restricted. 6s, it's not that restricted. We know in row 2, it cannot be any of the filled out. 1s can't be here, so it must be here. Still not that restrictive. 7s, we have 8 7s. We know where the last 7 has to be. It has to be there. 8s. 8s are not that restricted. 9s. We have 8 9s. We know where the last 9 has to be. It has to be there. So let's continue on. We have 1. Now 2 is very restricted. In row 2, it has to be here. That gives us 8 2, so we know where the last 2 has to be. It has to be there. 3 in column 5, we know where the 3 has to be. It has to be there. That gives us 8 3, so we know where the last 3 has to be. It has to be there. 4 now. 1, 2, 3, 4, 5, 6. We have all the 4s. 5. 5 is still not restricted enough. 6s. 6 in column 6 cannot be here because of the 6 in the box. So this must be 6, which makes this 5, which makes that 6. So that should give us all the 6s. 7, we have all 9. 8, we don't have all 9, but we know in row 1, 8 has to be here. That gives us 8 1s, so, sorry, 8 8s, and we know where the last 8 has to be. It has to be here, which leaves this as a 5. And that's the solution. Yeah, fairly straightforward. It's in between very easy and easy for me. I've done a lot of Killer Cage Sudoku though, and also just anything adding up numbers and stuff. So I know a lot of these sort of shortcuts sort of by heart. But yeah, I mean, it's pretty straightforward. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.